Hello everybody, this is the last video for section 9.1 basic ideas of differential equations. So we're going to discuss the objective number 3, solving initial value problems. Let's take a look at the first problem. We have the derivative of a function, unknown function, is 4 secant squared 2x. And we have a condition that y of 0 is equal to 8. We have done something very similar to this at the end of Calculus 1. So this problem is not too difficult to solve, okay? All we have to do is integrate y prime of x dx and find that constant c, right? Okay, so we're integrating 4 secant squared 2x. Okay, the antiderivative here would be tangent of 2x, and by the chain rule, the constant would be 2, okay, plus some constant c. Okay, so this would be the general solution to this differential equation, but because we have initial condition, we can find a particular solution. Okay, so y of 0 is 2 times tangent, 2 times 0 plus c, okay? And tangent of 0 is 0, so this is 0 plus c is equal to 8. So from here, c is equal to 8. So our particular solution for this differential equation, okay, what is it? It's 2 tangent of 2x plus 8. Okay, so this expression right here, this is the general solution. And I don't mean just the c, the whole expression, right? Okay, general solution. The one that we found over here, this is particular solution that's associated with this initial condition. Okay, so that's your first problem where you have the first derivative and one initial condition. Now, what if we have the following? Let's say the second derivative is given, and it's 4e to the 2x minus 8e to the negative 2x. Okay. Now, remember, we need to find u of x so that it satisfies this equation, right? So the second derivative of u is this, okay? Which means what? We have to integrate twice, but that means we need to have two initial conditions. So one of them is that u prime of 0 is 3, and then u of 0 is 1. Okay, notice that typically you will have u prime of 0 or u of 0, but that's not necessarily the case. Okay, sometimes these values could be different. Okay, it doesn't necessarily have to be 0. So let's go ahead and solve this problem. Okay, u prime of x would be the integral of 4e to the 2x minus 8e to the negative 2x. Okay, this will give us 2e to the 2x plus 4e to the negative 2x plus c1. Okay, now we use the initial condition that u prime of 0 is equal to 3. So this is 2 times e to the 0 plus 4 times e to the 0 plus c1. That's equal to 3. Okay, so that's 2 plus 4 plus c1 is equal to 3. So from here, c1 is negative 3. Okay, so we used this initial condition to find our first constant. We're still not quite done. We need to find the actual function. So u of x is the integral of what? It's the integral of 2e to the 2x plus 4e to the negative 2x. Now we know what our constant is. It's negative 3. Okay, this is straightforward to integrate. This would be e to the 2x minus 2e to the negative 2x minus 3x plus c2. Okay, and now we're going to use this condition right here to find that c2. So u of 0 is e to the 0 minus 2 e to the 0 minus 0 plus c2, and all of that is equal to 1. So what do we get? We get 1 minus 2, which is negative 1, plus c2 is equal to 1. Okay, so from here, c2 is equal to 2. Okay, which means our solution, now we can put it all together, our function is e to the 2x minus 2 e to the negative 2x minus 3x plus 2. Okay, so these are the constants that we can find by using our initial conditions. Okay, so notice this is second order differential equation, okay, with 2 initial conditions. All right, okay, thank you for watching.